So now today we are discussing the numerical of mechanical modeling, right? So in this case we are having mass m, k spring constant, b damper, the most commonly found containing all three elements. So this is the example of translational motional. Okay, so let us consider the shock absorber of a car like this. Of the mass we can model it below, right? Like suppose car is there, car wheel is there, and car is applying force sorry, in the right direction, correct? Yeah, the tire of the vehicle itself can be considered as an object with mass, right? And the elasticity of the tire can be considered as the spring, right? So we can model the tire as, suppose this is the tire of the system. Tire is represented by mass, right? And the elasticity of the car is represented by spring, that is K, and then in that case it would be fixed. Understood? Clear? So now in this case there is a angular movement, correct? In this case there is a angular movement. So in this case we'll consider the rotational motion, right? So in the rotational motion we'll having torque. So torque for inertia, like suppose this is the circular object, right? A torque is applying in the upward direction, right? That is T J T. So T J T would be equal to J alpha T. Alpha is the acceleration, right? Is equal to J. Alpha is equal to how much? Acceleration is equal to d by dt of velocity. So it would be d omega of t by dt, and it would be j d square theta divided by dt square, right? Remember I told you in this case we'll have torque, like we'll have displacement, we'll have angular displacement that is represented by theta, like we'll have velocity, we'll have angular velocity that is represented by omega, then we'll have acceleration that would be d2 theta divided by dt square, correct? Understood? Alpha t we can write it down now, that is dv of t by dt, right? And v of t we can write it down x of t by dt, right? So it would be d2 x of t by dt square. Understood this portion? Now see the numerical based on your tute. They have given the damper like this, that is connected with the spring, and spring is connected with the fixed point, right? They have applied force f of t in this direction, then there will be displacement of x of t, then the spring will be displaced by y of t, and you need to calculate ys divided by xs, that is the transfer function, correct? Now see how can we determine the transfer function for this case. That is, as you know, FB, let us consider the force applied for the damper is FB, right? And the force applied for the spring is FK, okay? So force it is moving like this. So force mainly act on this FB, right? Then spring is moving in the opposite direction, right? Because if you press the spring, then in that case it will be extended, so it would be F of K, correct? So because why we are saying, because equal and opposite reaction are equal, like opposite reaction are always equal, right? So we can say that FB is equal to FK. According to the Newton's third law of motion, to every action there is an equal and opposite reaction, right? So for the damper, what we can state that B into dx by dt minus dy by dt, right? Because they are in the opposite direction, is equal to Fk is Ky, right? So we can represent it like Bx dot minus y dot is equal to Ky, right? Next we can take the Laplace of this, then it would be B into S of x's minus S of y's is equal to K into y of s, right? So it would be Bs x of s minus Bs y of s is equal to Kys, right? Now we can shift this ys to the another side, right? So it would be how much? Bs x of s is equal to K y of s plus Bs y of s, right? Now we can take y of s is common, then it would be Bs divided by K plus Bs, right? And then I shift x of s is here, right? So this is your final answer of the transfer function. After that, we'll move towards the next question, question number 2. Here you can see the fixed point, right? And it is connected with the spring, right? And it is connected with the mass. Okay. Now this is F of t, B damper, K spring, and it would be x of t. Now you need to calculate x of s divided by f of s. Try this first by your own, then I'll tell you, okay? Okay, now see, I'll tell you how we can do these kinds of question. As you know, this is the mass, right? Here, force is moving downwards, so spring force we are applying like this, right? If to every action there is an equal and opposite reaction, so it apply a force on upward, that is F of K, right? It applies force on upward F of B, right? Similarly, for this one, the force is F of T and the force applied is F of M. So if I want to equate it, then F of T is equal to F of M plus F of B plus F of K, equating forces from the free body diagram of the mass M, right? Because both all are in the same direction, correct? Now as you can see that this mass is connected with spring, this mass is connected with damper, and mass itself force. Both are moving in the upward direction. They are at the same direction. That's why these forces are added with each other. Got this point? Opposite and equal reaction. Okay. Hmm. Right? Understood? So, in this case, it would be how much? F of t is equal to Fm. That would be d2x by dt square plus b into dx by dt plus k into x. Now we need to take the Laplace of this one. F of s would be m into x square x of s plus bs x of s plus k into x of s, right? If I'll take x of s common, then it would be ms square plus bs plus k. So x of s, they are what they are asking in the question, x of s divided by f of s. That will become 1 by ms square plus bs plus k. This is the answer. Now move towards the next question. In this, they said there is a spring is connected between mass and then we'll have damper. Another point is the fixed point. Okay. So here force is applied F of t. Here displacement would be x of t. Mass would be displaced by y of t. Okay. You need to calculate ys divided by xs. Right? Now, how can we solve this? As you can see, we need to see for the mass. Right? Mass is here. Force is applied for the spring in the downward, that would be Fk. Force applied for the damper, that would be Fb. So we can say that Fm is equal to, we can say that Fk is equal to Fm plus Fb, right? Mass is, yeah, or we can say Fm is equal to Fk minus Fb. One and the same thing. So Fm is how much? M into d2y by dt square, right? Fk is how much? K into x minus y plus Fb is how much? B into dy by dt, right? Then convert this equation into the Laplace form. See, if you'll solve it, then you will get as ys by xs is equal to k divided by ms square plus bs plus k. Okay, you got the same answer or the different answer? Hmm? Same? Hmm? Now question number 4. They have given you mass, damper, spring, okay, and that is connected with a single point. This is, they have mentioned f of t, it is displaced x of t, and movement is given y of t, right? You need to calculate again ys divided by xs. Now see how can you do these kinds of question. In this case, again we'll focus on mass. There is a mass, right? So spring is moving. Uh, there is a mass. In this case, damper is moving in the downward direction. Spring is forcing in the downward direction, and mass itself direction is in the above direction, right? So if I want to make the equation, then it would be how much? Fm is equal to Fb plus Fk. So Fm is how much? M into d2y by dt square plus b into dx by dt minus dy by dt plus k into x minus y. Now you need to convert it into the Laplace form. That would be m into s square y of s is equal to b into s into x of s minus s into y of s plus k into x of s minus y of s. Then you will get y of s divided by x of s is bs plus k divided by ms square plus bs plus k. Got it? Now the fifth question. They have connected the spring with the mass and then with the damper, and then two springs are there. Okay, this is a fixed point. In this they have mentioned f of t in the downward direction, then spring displaced by x of t by xt direction, then mass is displaced by y of t. This is K2, this is K1, right? This is B damper. And we need to calculate Y of S divided by X of S. Correct? Now see how can we do this. Place a mass, right? Now as you can see that there are two springs, right? In this case, spring is moving in the downward direction. So spring force is in the downward direction, right? Now in this case, it is damper is moving in the upward direction. It is F of B, and spring K2 is also, force is also on the upward direction Fk2, and force of the mass will be in the upward direction. Okay. So in this case, what would be the equation? Fm plus Fb plus Fk2 is equal to Fk1, right? So Fm is how much? My double dot. Fb is how much? By dot plus K2y is equal to K1 x minus y. Understood? So after solving this, you will get the answer as K1 divided by ms square plus bs plus K1 plus K2. You get the same answer or the different answer?